All right, hey guys, today we're going to talk about our first type of, or a new type of angles. We've got vertical angles and we've got adjacent angles. Okay, so let's get these blanks filled in first. So vertical angles are a pair of opposite angles formed by two intersecting lines. Okay, vertical angles are congruent. Okay, so let's take a look at this. So here we've got two lines that intersect. Okay, so because two lines intersect, the angles that are opposite from each other are called vertical. And what we know about that is that they're congruent. So if the angles are congruent, then that means the measures of each angle of the vertical angles are equal. Okay, so the measures of the vertical angles are equal. All right, so again, we've got two lines that intersect. So they form vertical pairs. So if you look at this, 1 and 4 are opposite from each other. So that means 1 and 4 are vertical angles. Okay, and they are congruent to each other, so their measures are equal. 2 and 3 are opposite from each other. Okay, so those are vertical angles. So they are congruent to each other, and their measures are going to be equal to each other. So 2 and 3. So we could say angles 1 and 4 are vertical. Okay, and vertical angles are congruent, which means their measures are equal. And then 2 and 3 are vertical angles. Vertical angles are congruent, which means their measures are equal. Okay, so they almost kind of form like a V if you look at this. So like here's the V and the V, like two V's for vertical, right? Or you can look here, like there's the one and the other, and they kind of share that same middle vertex point. Okay, so now let's talk about adjacent angles. Adjacent angles share a common vertex and a common side, but have no interior points in common. Really, all adjacent means is that they're next to each other. It doesn't say anything about their angle measure. It doesn't say anything about if they're congruent or not congruent. It just means they're next to each other. Okay, so let's take a look at this picture. FGH, so if I start at F, go to G, and then go to H, is going to be adjacent to HGM. So start at H, go to G, go to M. Okay, they're adjacent because they share this side right here. They both share this GH side, so that means they're touching, they're next to each other. Those are considered adjacent. It doesn't tell us anything about their size, anything about their measure. It's just a vocabulary term for next to. Okay, now if you look here, it says FGH, so that would be like this little guy is not adjacent to FGM. So if you look at this, here's F, G, and M, and then they said FGH. Okay, those aren't, because really FGH is inside FGM, so they're not next to each other. One kind of engulfs the other, so that's not considered adjacent. So adjacent is just next to, and they share that one common side. Okay. All right, so let's go down to the bottom and answer a couple questions. It says, tell which of the following described given the pair of angles. More than one can be right. Complementary, supplementary, adjacent, or vertical. So let's take a look. All right, so this first one, angle TAR, so T to A to R, and then angle RAP. Okay, well, if I look at this, these two are next to each other, and they share this RA side right here. So those are going to be adjacent. Okay, they don't add to 90. They don't form a straight line. They are next to each other. They're not opposite from each other. So adjacent is going to be our only answer there. All right, the next one, TAR. So TAR again. So this guy right here again. And then HAT. So HAT. Okay. Well, if you look at this, these guys, they share this side right here, right? So HAT and then TAR, they share this middle line right here. So those are going to be adjacent. Okay, anything else? Let's see. Complementary, do they form a right angle? Well, let's see. If I look at this here and this here, when you put them together, really it does. We've got this guy and this guy together does form the L. So yeah, these are also going to be complementary, because they form that right angle. Okay, they're not supplementary, they don't form a straight line, and they're not opposite each other, so it's just these two. All right, let's take a look at the next one, RAH. So R to A to H. So R to A to H. Okay, I got that one. And then HAM. So H to A to M. Okay, well, they share this guy right here. So again, they're going to be adjacent because they're touching and they share one line in common. And then what's C? Are they complementary? Well, no, because this is 90 and this is 90, so they can't add to 90. Are they supplementary? Well, look, yeah, here's my start. Here's my end. If I put that and that together, I get that half circle, right? That half circle, or the two endpoints, form a straight line, so 180. So actually, yeah, these are going to be supplementary. And then they're not vertical because they're not opposite each other, not diagonal from each other. All right, let's take a look at the next one. So we got TAR. Can't even see my picture anymore, but TAR, we're going back to this little guy right here, right? And then we got MAN. So M to A to N. So right here and right here. Okay, they're not adjacent because they don't share a side in common. Okay, complementary, I don't think they add to 90. They're not next to each other to form an L. Supplementary, no, they definitely don't form a straight line. But vertical, yeah, look at this. So I got my V here and my V here, and they kind of share that point in the middle. So yeah, those are going to be vertical. Okay. All right, now it wants us to find the measure of TAR. All right, well, I've totally ruined this whole picture. So let me just redraw this. Hold on one sec. Okay, guys, sorry. I totally destroyed this picture up here, so I just kind of redrew it for you. So now, let's see. It wants us to find TAR. All right, so let's see. There's going to be a lot of different ways we can do this. Actually, for this one, it's pretty obvious. So if MAN is 45, or 43, okay, and TAR is diagonal from it. See how they're diagonal and they kind of form that V? Those are called vertical angles, which are congruent, which means their angle measures are the same. So that's also going to be 43 degrees. So see how they're opposite from each other, and they kind of form like, here's that V, right? Okay, so vertical angles are congruent. So if this is 43, that's also 43. Okay, then they want us to find NAP. Okay, so NAP. So this guy right here they want us to find. Well, if you look at this, right, this is 90 right here. And remember we talked about the other day, if this is 90, that means that's also 90. So this whole thing, this MAP, that whole thing is 90, right? Well, I already know that this chunk of it is 43, so now I need to find this chunk. So that's just complementary angles, right? Two angles that add to 90. So I just do 90 minus 43, and I'm going to get 47 degrees. So this angle right here is going to be 47 degrees. Okay, I knew that because this is 90. So this is perpendicular. So if this is 90, this whole thing has to be 90. Right, so if this piece is 43, then 90 minus 43 gave me the missing piece. So 47. All right, flip over your paper.
Okay, so we have some true or false questions. And the very first one says, complementary angles are always adjacent. So now the key word here is always. So they're not always adjacent. So that's a false statement. Adjacent means that they would have to be next to each other in order for them to be complementary, and that's not true. To be complementary, they just have to add up to 90 degrees. So we could have like two separate angles. Like we could have an angle over here, and we could have like an angle over here, and maybe this was like 60 degrees, and maybe this is 30 degrees, and together it makes 90. Those could be complementary. Vertical angles are always complementary. So angles that are across from each other always add up to 90 degrees. Well, that's not true, because angles that are across from each other could be anything. Vertical, they would just be the same. They don't have to be complementary. They could be, but they don't have to be. Two right angles are complementary. Well, that's not true, because if I have two right angles and both of them being 90 degrees, then there's no way that they're going to add up together to equal 90 degrees. Two right angles would actually be supplementary, not complementary. Vertical angles may be adjacent. Vertical meaning across, adjacent meaning next to. Well, if something's across from something, it can't be next to something at the same time. So that is false as well. So those were all false statements. Use the picture to the right to answer the questions below. It says, name the angle that is vertical, 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 vertical meaning across to the angle that's given. So here I have angle FGB. A. I got to follow from F to G to A. So we're talking about this angle here, and I want the one that is vertical or the one that's across. So if I'm looking at F to G to A, I want to look directly through that intersection, and it looks like I'm looking at C to G to D. So angle C, G, D. And make sure you use that little angle symbol. Angle FGE. So if I'm looking from F to G to E. So from F to G to E, I got to follow those letters from one to the next to the next. So if I'm looking across, directly across, I'm looking at B, G, C, because those ones would be directly across from each other. So I'm looking at angle B, G, C. Now I'm looking at angle AGE. So I want to find angle AGE, and I want to look across. So I got to follow my letters again. From A to G to E. Now that's a wider angle, so I need to look at something that is wider sitting across. So I'm looking at B, G to D. Those are vertical angles. Angle BGD. Now I'm looking at AGB. So if I'm looking at angle AGB, I got to follow from A to G to B. So now I'm looking at this angle in here, A to G to B, AGB. I'm looking across what is vertical, directly across, and it's going to lead me to EGD because it's directly across here. So I'm going to color that in for you, EGD. So angle, there's my little angle symbol, EGD. Okay, now it's asking us some questions based on that picture. Are angle AGE, so here's A to G to E, and EGC, here's EGC, are they adjacent? So they want to know if they're adjacent. Adjacent means sitting next to. So are these two angles sitting next to each other? So if I have AGE, that's this whole section in here, and I have EGC, E to G to C, that's this whole guy in here. Are these two sitting next to each other? Are my colors touching? And they are. So in this case, I would say yes. They are adjacent. And it's because they share a common side. They share a common side, and it's because they share that common side that they are then adjacent. They're touching, and it's because of this side right here that this angle links up with this angle here. BGD and DGC, are those adjacent? Are those sitting next to each other? So I'm going to look at BGD. So from B to G to D, okay? So that's this angle here, BGD. And now I have DGC, from D to G to C. So that's like this one that's sitting then on the inside here. So now it's asking, are these two adjacent? This angle here within then this larger angle here. And in this case, I'm going to have to say no, they're not adjacent. And that's because they share interior points. And it's because they share those interior points that means one of those angles is on the inside of the other angle. So if something's on the inside of one angle, it's not sitting next to it. Okay, so I can't be having an overlap of angles and say that they're sitting next to each other, because if they were, it would look more like our yellow ones that we shaded in there. Okay, if the measure of angle BGC, so that's right here, BGC, that's this section of angle here. If that was 34 degrees, then what is EGF? So I'm looking at E to G to F. So now I'm looking at this over here. Well, if I know this is 34 degrees, and this is directly across, which means that it's a vertical angle, that means that this chunk of my picture must be 34 degrees as well. It's because they're vertical angles. Vertical angles are congruent. Their measurements of 34 are equal because those pictures are congruent. Measure of angle AGF. So from A to G to F. So I'm looking at this guy in here, A to G to F. So I'm thinking if that's 52 degrees, according to what my question says here, they want me to then find BGD. So let me find from B to G to D. So that's like this whole section in here. So if you can see where my green is starting to engulf this whole chunk over here, well, if I want to know what this whole piece is here, if I know this is 52, and looking directly across this smaller chunk over here of my angle must be 52, and I already know that this piece over here is 34, and together these two pieces make up this angle that they're asking me to find. So between my 52 and my 34, that must be this entire angle here. So I have my 52 degrees plus the 34 degrees that they gave me. So altogether, it looks like we have 86 degrees. Using the information above, find the measure of angle EGD. So now I got to find EGD. So I got to follow my letters from E to G to D. Okay, so now that's looking at this whole guy right here. We're looking at this big orange angle that I'm coloring in there. So EGD. Well, based on the information that I have here, I can look and see what makes a straight angle. I feel like that is the easiest way to go about it. When I'm looking at this picture, the thing that sticks out to me the most is this straight line that's running right through there. So if this whole section I need to find in the other part of this section, I already know what it is because I already added it together right here to give me 86 degrees. So if this is 86 degrees and all together I know that it's 180 because straight lines give me 180 degrees, I can just subtract, because if the whole thing is 180 and 86 is what I know already exists, I'm going to subtract to see what is left behind. And that would then leave me with 94 degrees. Okay, so there's my answers right there for those two. Use the figure to the right to answer the following questions. So now I'm looking at this picture with the 1, 2, 3, 4. If the measure of angle 4 is 123, so here's my angle 4, giving me 123 degrees, then they want me to find 1, 2, and 3. Well, the easiest thing to find first is this guy right here. They're vertical angles. They're sitting across from each other. Angles that are vertical are congruent, so if this guy is 123, then the measure of angle 2 has to be 123 degrees as well. Now, if I'm looking at these as lines, because these are straight lines here, if this much is 123 and the whole thing together gives me 180 degrees altogether, then I can subtract away the 123 that I know already exists to find what's left. So in the case of angles 1 and 3, I'd be doing the same thing. If this is 123 and the whole thing is 180, if I do 180 minus my 123, I'm left then with 57 degrees. And if this is 57 degrees and these two angles are vertical, then this has to be 57 degrees as well. So both of these are the same, 57 degrees. So what angle is vertical then to angle 3? So I'm looking at angle 3 and I'm thinking angle 1, sitting directly across. Which angle is adjacent or sitting next to angle 2? So here's angle 2. Looks like angle 1 is sitting next to it, and also angle 3 is sitting next to it. So as far as vertical goes, sitting across, we have angle 1 being directly across from 3, and then who's sitting next to angle 2? Next to, next to, next to. Here's one next to it. There's one next to it as well. Okay, so there's your difference between vertical and adjacent. Adjacent is next to, vertical is across. And we will see you guys soon. Thank you.